Good morning, students. Today we are going to see a new lesson, that is nuclear physics. Unit 6, nuclear physics. Okay, students, right? Okay. In last class we discussed in Unit 5 1 marks. That is fifth lesson 1 marks we discussed. Okay, students. So fifth lesson is over. Therefore, today I am going to start a new lesson. Okay, students, nuclear physics, right? So, nuclear physics. So, see that nuclear and physics. So, definitely, if you have, if I am taking the nuclear word, so definitely what will present? Atoms. Okay, right? Atoms, because in universe all the objects made up of what? Atoms, right? All the yes parts, okay, all the things made up of atom. Okay, students, right? Yes, shall we go to the topic? Right. First, what is nuclear physics? Some small definition of nuclear physics. Okay, see this. Nuclear physics is the field of physics that studies the building blocks and the interaction of atomic nuclei. Nuclear physics is a field of physics that studied the building blocks and the interaction of atomic nuclei, right? And it includes the study of it includes the study of general properties of nucleus and the particles contained in the nucleus and the interaction between these particles, and radioactivity and nuclear reactions. Radioactivity and nuclear reactions, right? And practical application of nuclear phenomena. Practical applications of nuclear phenomena. So the nuclear physics contain these things. Okay, students, right? Now come to nucleus, right? So already you know is about nucleus, right? See the nucleus. So what is nucleus? We know that the center of atom is nucleus, correct? Okay. So what is the atom size first? See the atom size almost is equal to 10 power minus 10 meter. 10 power minus 10 meter, that is the atom size. And the nuclear size almost 5 into 10 power 15 meter. 5 into 10 power 15 meter. This is the size of what? Nucleus, right? Okay. Now come to this one. Every atom contains a center, an extremely dense and positively charged nucleus, right? So every atom contains a center. That center is nothing but nucleus. An extremely dense positively charged nucleus, right? Okay. And next, The nucleus is made of protons and the neutrons. So nucleus made of protons and what? Neutrons. Okay. And next, protons have positive electric charge. Protons have positive electric charge. And neutrons have no electrical charge. Right? Therefore, protons have positive charge due to this reason. Nucleus has positive charge. Which charge? Positive charge. Okay, students? Right. Now, come to this one. If that atom represented by S based on that, if that atom has elements represented by numbers, that is mass number and atomic number. Okay, so here some details about nucleus. Okay, because nucleus has protons and neutrons. Okay, the first one, the total number of nucleon. Total number of nucleon A. Yes, that is, if you are consider total number of nucleons is nothing but mass number. The mass number represented by A. Mass number represented by A. Okay, that is equal to protons plus neutrons. Number of protons and number of neutrons. Okay, and the next is atomic number. The atomic number represented by Z. Atomic number represented by Z. So this atomic number based on number of protons. Based on number of protons. Okay. Next, neutron number N. Neutron number N is nothing but number of neutrons. The number of neutrons. So N represented by number of neutrons. And now come to the radius. Radius of the nucleus. That is equal to SR naught A power 1 by 3. Yes. This is the constant value. You don't worry about this one. Okay. Now is R naught value is the radius of the nucleus. Nucleus is 1.25 into 10 power 15 meter. 1.25 into 10 power 15 meter. Okay. Now the mass, right? Mass is equal to A. A is atomic unit. A is that atomic unit, right? Atomic unit. Okay, that is U is equal to 1.66 into 10 power minus 20 kg, right? Mass of nucleus. So the unit is atomic mass unit. Okay, students, right? So come to this side. Here I am taking carbon. Yes, see what carbon? Yes, their atomic mass is 14, that is C14 6. So atomic mass 14. Okay, and the 6 is that atomic number. Mass number is 14, that is atomic mass. Okay, and how many number of neutrons? Neutron number 8 is the neutron number. See this, the mass number represented by mass number is nothing but number of protons and the neutrons. Yes, sum of protons and neutrons. Okay, right. And next, nuclear force. What is that? nuclear force. The force that binds together protons and the neutrons inside the nucleus is called nuclear force. The force that binds together protons and neutrons inside the nucleus is called the nuclear force. Okay, right. Next, some characteristics of the nuclear force are: the nuclear force has some characteristics. The characteristics are: it does not depend on charge. The nuclear force does not depend on charge. Okay, and it is very short range force. It is very short range force. It is much stronger than the electric force. So stronger than electric force. It is saturated force. It is saturated force. And it favors formation of pairs of nucleons with opposite spins. Okay, so these are the characteristics of nuclear force. Okay, students, right? So fifth point, of nucleons pairs opposite spin. If you go to higher class, and you will know. Okay, but you should know this one, nuclear force. What is nuclear force? Okay, right. Now come to the radiation. Yes, come to radiation. Okay, so radiation is very important thing in radioactivity, right? Radioactivity. Okay, students, right. First, radiation. So radiation is nothing but energy in transit in the form of high speed particles and electromagnetic waves. So radiation is nothing but energy is transit in the form of high speed particles and electromagnetic waves. That is what? Radiation. That is what? Radiation. Right? Okay. And the radiations are classified into basically two types. One is ionizing radiation, another one is non-ionizing radiation. See this one and this one. Radiation with enough energy. Radiation with enough energy. During an interaction with an atom, it can remove electrons from orbital, causing the atom to become charged or ionized. Example, gamma rays, neutrons. Right? And if you go to that ionizing, non-ionizing radiation, this radiation without enough energy to remove electrons from atoms. Right? Without enough energy to remove the electrons from atoms. Examples: non-ionizing radiations are visible light, radio and television waves, and ultraviolet rays and microwaves with large spectrum of energies. Okay, students, right? Okay. Now come to the radioactivity. Radioactivity. What is radioactivity? The spontaneous transformation of an unstable atom and often result in the emission of radiation. So radioactivity is nothing but the spontaneous transformation of an unstable atom, and often result in the emission of radiation, right? So from this radioactivity is from the materials also. First one, radioactive material. So there are two radioactivity is will be there. One is natural radioactivity and another one is artificial radioactivity. Yes, I'll tell you later what is artificial radioactivity and natural radioactivity materials. Okay, now come to this point, radioactive material. If any material that contains radioactive atoms which emit the radiation. Okay, now come to this side, radioactive is contamination. If the radioactive material distributed over some area or equipment or a person. Okay, so unstable atom emits radiation. Okay, that is basically natural radioactivity. Okay, students, right? And now come to this brief background radioactivity. See, this is the picture of Henri Becquerel. He is a French physicist, right? So he put different element in the sun and placed them on a photographic plates in the dark drawers of study of photo is in phosphorescence. One day in 1896 there was no sun and he put uranium on a photographic plate in the dark drawer. So uranium is the material, and the next day the plate was cloudy. So energy was coming from the uranium itself. Okay, and see this is the picture of Mary and Pierre Curie and Poland and France. See this, Mary and Pierre Curie spent years purifying radioactive elements. Okay, and they discovered new radioactive elements are radium and polonium in 1898. Yes, so radium and polonium are radioactive elements. These elements naturally emits radiation. Okay, right. And yes, both died because they were exposed to radioactivity which is caused by toxicity in their body. Okay, students, so Marie Curie discovered radioactive elements like radium and polonium. Okay, students, right? Okay, and now, and here is the Rutherford picture. Rutherford found 3 different types of particles were emitted. He called them alpha, beta and gamma particles. Alpha, beta and gamma particles. Okay, students, right? He called them alpha, beta and gamma particles. Okay, students, right? Now come to the radioactivity. What is radioactivity first? is the emission, right? So therefore this emission is not affected by temperature. This emission not affected by temperature, and could change color of glass, is and burn skin and to create heat. Okay, right? So the atom is not an indestructible unit. Okay, so it is the emission, right? So see, this is the exact radioactivity. So if you are taking that radioactive atom, unstable nucleus, yes, emits that energy, that is radiation. It gives the particle also. So unstable nucleus spontaneously emits small particles. So stable atom, unstable atom, we know that. So unstable atom or unstable nucleus spontaneously emit small particles and our energy in order to attain a more stable nucleus state. Okay, students, right? Okay, I already said types of radiations are non-ionizing radiation, ionizing radiation. Based on that energy, the non-ionizing radiation has low frequency, that is low energy, and the ionizing radiation has high energy, that is high frequency. Okay, right? Okay, and see, this is that the nuclear reactors. So this is the nuclear power, yes, plant. So this is the structure of that core, yes, nuclear core. So this nuclear core, in this nuclear reactors, in the core they are using radioactive materials like uranium, yes, radium, polonium, yes, these are the what? Radioactive materials. So radioactive materials emits radiations like alpha, beta and gamma rays, gamma particles, right? Okay, students, alpha, beta and gamma, right? Radioactive elements which emits these radiation is called as radioactivity and radioactive elements. Okay, students, what are the radioactive elements? Radium, uranium, thorium, polonium. Yes, these are the radioactive materials or elements. Okay, students, right? Okay, right. Students, just these are the introductions, okay, students, about nucleus and radioactivity and history of radioactivity, nuclear physics. Okay, so next class we'll discuss the book content. Okay, so the book content is nothing but what is the artificial radioactivity and new natural radioactivity and the elements and the difference between the natural and artificial radioactivity, that and all. Okay, so in next class we will discuss that exact book content, but these are the important things. Okay, students, okay, right? Okay, students, we'll see you on next class. Okay, thank you.